Thank you for coming. Welcome to Deciding with Data, How Society Can Use Algorithms to Make Better Choices. My name is Joshua New. I'm a policy analyst at the Center for Data Innovation. For those unfamiliar with us, we are a nonprofit, nonpartisan public policy think tank studying the intersection of data, technology, and public policy, and we're affiliated with the Information Technology and Innovation Foundation. So I just want to start with some bad news. Unfortunately, Greg Godbout, who's going to be joining us, is stuck in traffic in Northern Virginia in a dead stop, and he doesn't think he'll be able to make it. So we are going to miss him in the discussion, but we have some very talented panelists that can cover for him, I'm sure. So to kind of give some background on today's event, we live in a world of increasingly big data, and it's only getting bigger. So we now have enough information and ways to capture this information where we can start translating this information directly into action. We can automate decision-making, we can rely on algorithms to make smarter choices, to be more efficient, and to even be more equitable. But this is not without its challenges. Just last week, a police officer in Mountain View, California, pulled over a car that he realized did not have a driver for going 10 miles under the speed limit. Fortunately, there was a passenger in the car, a Google employee, who was testing the pilot, and explained that Google self-caps its cars at 25 miles per hour for safety reasons. The officer issued a warning and went on his way. But what if the car was going 10 miles per hour over the speed limit? What if there was no passenger to explain how the car chose its speed? I'm sure the tone of the news articles would have been much different. I envision headlines of Terminator car run amok in Mountain View. And so this is a lighthearted example, but it really encapsulates the idea that as a society, we don't really know how to approach algorithmic decision making. It's a new technology, and usually when that happens, it's often met with fear. So recent reports from the White House, from the Federal Trade Commission, countless other researchers and articles have issued some pretty dire warnings that big data and algorithms will necessarily be a detriment to society. They'll ingrain human bias. They'll automatically discriminate. But missing from this conversation, and I think from these criticisms as a whole, is that the world is already full of bias, and discrimination already permeates human decision making. So algorithms are an incredible opportunity to actually reduce this bias and expose bias where we think there is none or we have no way of measuring. So this is the concept of the tyranny of the algorithm. Whereas we like to suggest that as a technology, it's not without its downsides, but it does present a tremendous opportunity to have a more just and equitable society. So hopefully today we're going to talk about we're going to go into the pros and cons of algorithms and bring a much needed balance to this discussion. So very happy to have, unfortunately, Greg Godbout cannot join us. We have some very talented panelists with diverse backgrounds that can all bring some interesting perspective to this panel. We have Bob Suter, Vice President of Business Solutions and Mathematical Sciences at IBM Research. We have Courtney Bowman, who is Co-Director of Privacy and Civil Liberties Engineering at Palantir Technologies. And we have Madeline Elish, who is a researcher at Data and Society's Intelligence and Autonomy Initiative. So just run of show, I'm going to ask each panelist to introduce themselves and talk a little bit about their work. I'm going to start, and then we're going to go into moderator Q&A, and then we're going to do audience Q&A. And so we are live streaming this. It's available on our website. So if you're live streaming or you're live tweeting, feel free to tweet at us with the hashtag Data Innovation. All of our Twitter handles are up on the board. And there will be an opportunity for Twitter Q&A and the audience Q&A as well. We'll have Sam flag interesting questions. So also in the back, feel free to leave a business card if you'd like to stay up to date about what the center is doing. Grab some articles and some irreverent stickers that we like to think make us funny. And so let's get started. Bob.
What am I pressing?
Should turn green.
Thank you. Okay. So as Josh said, I'm an executive in IBM Research, and generally speaking, I lead a group of several hundred applied mathematicians. And so what this means is the full range of mathematics, statistics, machine learning, yes, algorithms as a discipline, many other areas there. I want to start this discussion by, in fact, saying that if we look at the general population, most people don't have the vaguest idea what an algorithm is. But boy, maybe they should be scared of whatever it is, right? And just to maybe set the stage for some future analogies or metaphors, really, an algorithm is just a recipe for doing something. So any of you who tied your shoes this morning, congratulations. You used a little algorithm that told you which bit to put over the other bit and when to pull, and of course the traditional cooking recipes. And like recipes, some of them can be extremely simple and some of them can be extremely complicated. Most of them are what we would call deterministic. That is, you want to do something and you do one step after another, and eventually you hope you get to where you end up. Some have more probability associated with them. The fancy name for that is stochastic. Here, your algorithm is, you don't quite know exactly how you're going to get to the end, but you're hoping to get a pretty good result. Example here is if you're in the grocery store and you're trying to choose which lane to get into, right? Do you get in the shortest lane? Do you get in the medium-sized lane, right? And you don't know, but you're trying to optimize, and there are, in fact, algorithms for determining how to do this. Now, obviously, the algorithms we're talking about are a whole lot more complicated in that they may control cars, they may control airplanes, keep the trains running on time, and make decisions for you. So there have been many algorithms, of course, in healthcare. There are algorithms in the machines that you see if you're in the hospital or in the doctor's office. Increasingly, though, these algorithms are being used to give advice to professionals. That is, they are looking at your information. Presumably, you've signed your HIPAA form and everything like this, so everything is proper. But the algorithms are learning, they're looking at the data, they're looking at past cases, and they're trying to give good advice to whoever the professional may happen to be. So there's really quite a range. There's a range of doing them extremely well. They're like anything else, like cooking, again. Some people can really not cook. Some people can really not write algorithms in the same way. So there's nothing inherent about the algorithm itself. It's very much about the person or the people who are designing it, who are testing it. That's critically important. And for what end are you trying to do? So just before I turn over to Courtney, my area, therefore, while it's in the mathematical sciences, we work in many industries. We work in agriculture, where increasingly people are trying to do things like yield prediction to maximize the amount of food that's produced. That's a really nice algorithm to have, for example. We work in automotive, we work in healthcare, pretty much any industry where you would think math or computer science would play, that's where algorithms play today. So, Courtney?
And thank you, Josh, and thank you to the Center for Data Innovation for inviting me to speak on the panel. I'm Courtney Bowman. I'm a lead for Palantir's in-house privacy and civil liberties team. We're a group of folks that are dedicated to the proposition that the technology that we develop shouldn't come at the cost of infringements in privacy and civil liberties. So we work on developing technology that's also, I see someone. Is that any better?
The speakers
Are these overhead? Where's Harry? All right, so we'll project. We'll work on getting it.
I'll try and talk.
Sorry,
really
we're getting the speakers working.
So I work in a group that's focused on building privacy-enhancing technology, including algorithmic design. And to build on a point that Bob, I think, was getting at, is that I think there's a general understanding that algorithms are neither inherently good nor inherently bad. They're also not inherently neutral. And the thrust of that statement is that there's a lot of design decisions that go into developing algorithms and determining the grounds for their deployment. And built into that process are a number of decisions that need to be made in order to factor in the risks. And so coming up with an appropriate risk calculus for determining when it's appropriate to apply an algorithm, under what circumstances the algorithm should be trusted, and what sort of oversight and accountability mechanisms should be in place are critical determinants that we as a company factor into our decisions for algorithmic deployment. So I wanted to sort of set the scene for this notion of responsible algorithmic deployment, lay out a few conditions that we usually think about when we think about using algorithms for various types of applications. I think the foremost question that goes into this calculus is the question of efficacy. Algorithms can come in various forms, complicated, less complex, but the critical factor that should be evaluated is whether the algorithm is actually effective in doing what it's intended to do. In the absence of that, a lot of shiny algorithms oftentimes get used in scenarios where it seems like there's great promise, but ultimately their outcomes aren't nearly as hopeful as one would like. The other consideration that I think is critical in laying out a regime that deploys an algorithm for predictive purposes or other purposes is thinking about scope. Oftentimes algorithms are intended for a particular purpose, but over time get repurposed to overly broad applications for which they weren't originally designed and aren't ultimately applicable. And that scope or mission creep creates a lot of really detrimental issues in terms of potential infringements to civil liberties, privacy, civil rights risks. So knowing the scope of the algorithm at the outset and sticking to that scope, and then as additional applications come on board, thinking about qualifying those applications in a sensible way is one of the critical factors for having good algorithm in the field. A point that I think is borne out in some types of algorithms is a point that's harder to make more broadly as you think about the broad taxonomy of algorithms that Bob suggested, is this question of causality. Being able to come up with a good causal explanation about how the algorithm works. It's an important point to be able to address later on down the road whether the algorithm has acted appropriately. Now, causality is a harder thing to demonstrate when you're dealing with, for example, machine learning certain types of machine learning or non-deterministic algorithms, including neural networks, various machine learning types. But it can be a useful way of being able to explain how the algorithm works to the lay community and being able to get that community engagement and community feedback. Risks around disparate impact, as Josh has mentioned, a lot of the rhetoric around algorithmic risk, that algorithms can produce discriminatory impacts, disparate impacts to vulnerable populations. Those are things that need to be addressed in the design and ultimately in the oversight and use of those algorithms. Having a human in the loop in algorithmic decision making is another critical factor, particularly when you're dealing with outcomes that have significant human implications. For example, predictive policing is one area where we see algorithms that potentially run the risk of great infringement of personal liberties. So having someone in that process being able to review the outcomes, the decisions that are produced by the algorithm before an additional step is taken is a critical determinant in ensuring that the algorithm is not going haywire. That also gets to the point of legal processes and in some cases constitutionality, ensuring that the algorithmic applications factor in legal restrictions and also due process in applying that algorithm, particularly Fourth Amendment concerns in the predictive policing context and a few other contexts. General point of transparency, understanding how the algorithms work, and also this is a point not only about how the algorithms work, but also how the algorithms work with data. So knowing the quality of the data from the start, knowing how that data is processed over time, and ultimately how decisions are produced from that algorithm creates an environment where those algorithms can later be interrogated if there are questions, and there's a route for public redress for understanding if the algorithms may have done something untoward. And ultimately, and finally, a point that I'll make is that having policies and procedures in place around how the algorithms should be applied is a critical factor in ensuring that the algorithms are used in a way that's consistent in the outline of their original remit. So those are a cluster of considerations that we tend to think about when we think about algorithmic uses. I'm glad to go into more detail, hopefully in some additional context, but I'll turn the floor over to Matt.
And so I'm told that our speakers are still not working. Is this any better or no?
Yes, they is.
Okay, so speak right up into your microphone. Sorry about that.
Okay, how's this? It's okay? All right. So Josh, thank you so much, and thank you to the Center for Data Innovation. I'm really glad to be here. I think first I'll just tell you a little bit about data and society. We have some friends in the room. Then tell you more about the Intelligence and Autonomy Initiative that I am a researcher for. So as the name suggests, data and society focuses on intersections of society and data-driven technology. We're a small, newish, independent think tank in New York, founded by sociologist Dana Boyd. And our work involves identifying major issues that are upcoming, that maybe are not quite in the press yet, or are kind of the kinds of things that we need to think about before they actually get legislated in any meaningful way. And we develop original research and hold events to ground some of these emerging discussions. We're a mix of academics and practitioners, and another part of our goal is to bridge the work that is being done in academia in useful languages and useful frames for people working in industry and policy and whoever else is interested in thinking in some sort of unexpected ways. Actually, when Josh mentioned the tyranny of algorithms, I was thinking, in a way, Data and Society is a group of pro-technology people who want to fight against the tyranny of innovation. That is to say that just because something is new doesn't mean that it is better. So I think that sometimes we, for the sake of pushing the debate further, want to kind of complicate what is good about technology and what is bad. So we have 5 core research initiatives, which involve new empirical work as well as synthesizing existing work. Those core initiatives work around education, technology and education, civil rights, ethics and particularly the role that librarians play in future ethical data discussions, labor, and then the Intelligence and Autonomy Initiative. And so the Intelligence and Autonomy Initiative is a project that I co-lead along with my research partner, Tim Wong. Tim is a lawyer, and I am an anthropologist by training. So we bring a really interesting perspective to questions around machine intelligence. And we're interested in looking at the future policy implications and how we might think in a more productive way about the widespread deployment of machine intelligence. So in some ways, we say on our website we're connecting the dots between robots, algorithms, and automation. We kind of want to link all of these large terms that we that are thrown around in the media and try and understand what are the commonalities and what are the places where machine intelligence in specific industries need to be considered as such, but where they should be thought about holistically. So we produce research reports, hold events. Courtney was at an event we held last year, actually, and we author popular news articles. And our goal is to really shift the conversation around machine intelligence from hype and from fear. So very glad to be a part of this panel is trying to do that. But also to kind of think about it as a holistic social phenomenon, to think about it not just as technology focused, but actually as setting up new human and technological infrastructures. And so trying to bridge, I think, the way engineers might think about what's happening and to bridge the way policymakers might be thinking about what's happening, and to kind of see this as a larger social phenomenon. Just to give you a sense of some of our work, specific instances, we wrote a white paper about how the history of autopilot legislation historically might tell us something about the future of legislating driverless cars. So I think that also gives you a sense that we're interested in paying attention to history and how history might teach us about paths moving forward. We've also done work around algorithmic governance in Uber and other car sharing apps. And my own dissertation research has looked at Air Force RPA or drone operations and how that's changing the nature of military work going forward with new kinds of machine intelligence deployed in defense settings. So lots more to say. Really looking forward to.
Great. So I'd like to start off with something that both Madeline and Courtney addressed, the concept of human-in-the-loop computing. There are certain situations where when algorithms are not considered trustworthy or reliable enough to complete the decision-making process, there needs to be a human stage involved, either because, one, the algorithm just isn't there yet, or because the outcome is considered too important to leave to a computer system. Courtney, you mentioned predictive policing. Self-driving cars is an issue that this relates to quite a bit. And Madeline, you actually wrote an article about this called "Humans as Moral Crumple Zones," whereas should an autonomous vehicle, or a primarily autonomous vehicle, make a mistake, the fact that the human was in the loop might be a pain point where they would automatically be blamed for something that's not necessarily entirely their fault. But that kind of presents a counter-argument to the idea that we always need a human in the loop for these really important decisions. So how do we determine the difference between what is a good opportunity for humans to be there versus when they might be a liability, even when the outcomes are equally important?
I think that your question gets at a really important point. One thing to begin the conversation with is that, at least in the discussion around autonomous weapons, the conversation has moved from just having a human in the loop to having a meaningful human control. So that is to say, any human in any loop is kind of a meaningless statement. So we need to think about what is meaningful human control. And so I think that kind of gets us to more precise language about what are we trying to ask. I think, just to lay out for those who have not read our work so far.
You can all read it. It's a good article.
Is actually this emerges from our study of autopilots in aviation, and kind of looking at how the automation of the cockpit has meant increasing control is done by the computer system, right? So when you're flying in an airplane these days, probably the pilot is only directly in control for a few minutes out of every flight. However, according to FAA regulations, as well as what we've seen in the courts, pilots are ultimately responsible for what is happening throughout the entire duration of the flight. And so what we want to say is, well, actually, is that fair, or do we need to think about some new ways to account for how control and responsibility are distributed within a system? So is there some way to hold, in a more effective way, how autopilots are being, the designers of autopilots, since the autopilot is really in meaningful control, right, of the flight for most of the flight time. That said, right, you can't, there's a lot of mediated steps between a designer and an engineer and the hardware itself. There could be a good argument for why there's no way to hold those designers accountable for what happens, but then we also need a human, or we need some kind of moral agent to be held responsible. And I think I want to hold on to that. So I don't know.
There's also, I think, the very first autopilots, I would say, were not as reliable as what we have today, right? So going back to the algorithmic topic, people become more comfortable over time with certain classes of algorithms, or just trust, right? I mean, there's always going to be, there can be a mechanical problem that the autopilot can't deal with. But in any of these cases, and you have to get very specific. I mean, just building on one thing you said, there are some loops you may not need a human in, right?
Right.
You really cannot overgeneralize to one topic and say algorithms do this or do this always, right? So you have to be very specific. And thank you very much. And you have to look over time as well, right?
Yeah, I would just add another. That's an absolutely good point, and it also raises kind of another aspect about having a human in the loop, which is that what happens to the work that the human does, right? So part of the problem, which has been documented by human factors researchers, is that humans, the way that these current aviation autopilots work is that if there is some sort of edge case which the autopilot has not been programmed for, it throws the control back to the humans, because humans are good problem solvers. We we excel at kind of thinking in unexpected situations. The thing is that de-skilling is a serious issue in all forms of automated work. And so if pilots are not used to flying, they lose their flying skills. There are ways to airlines try and keep up training, but there's been studies that show that that's only relatively effective. So the sort of the roles that we put humans in, humans are really bad at taking over control all of a sudden. So that's another example.
A more trivial example is using calculators in elementary school. The de-skilling of people who can do arithmetic. Right?
Who can still spell.
So it's good to understand the fundamentals of whatever you're involved with.
Sure. So building off that, so I mean, the reasons humans are in the loop is because algorithms just are not considered, good enough to handle the whole process, or we, don't have the legal vocabulary to understand how they would be held responsible in that process. But what about? But I mean, that's today, right? So algorithms are, undeniably going to become more powerful, more robust, and at a certain point, for some situations, I'm not saying for all of them, they'll be undeniably more powerful and more reliable than humans. There's a reason we have semi-autonomous vehicles now as opposed to fully autonomous vehicles. But so when that shift happens, how do we go about convincing people, or how do you go about ensuring that humans human behind the wheel to take over should the system fail, when that is necessarily a liability as opposed to a benefit? Situations where you can imagine that transition happening in a couple of years, how do we kind of account for that? Because that's going to make people pretty nervous, I think.
I don't think there's an a priori way of determining how you get to that point. That's largely an empirical question of what are the risks associated. Again, looking at this question of efficacy, can you make a sound determination in context and figure out, is this a particular algorithm that's likely to produce, for example, false positives that have significant implications to the lives of people, or to risks around infringement, curtailing privacy or civil liberties or things along those lines. And then, based on that context, make a decision about, make a data-driven decision about that transition. Absent that information, it's really hard to make a compelling case to the public. But we do see contexts where you can make a more compelling case in community engagement by pointing to data and showing how the algorithms actually do provide a significant gain. But again, that gain has to be put in the context of what are the alternatives. And again, you probably also need some information to understand the alternative applications, whether there are other algorithms, whether there are more ad hoc policies or methods for dealing with decision making. So yeah, ultimately, I think there's a question around sort of gradually building a corpus of information that makes that more and more a compelling way of demonstrating the value of the algorithm, as opposed to asserting blindly that it's going to work. Because I think there's always going to be a natural resistance to that.
Okay. All right. Courtney, you talked about this, about incorporating principles of responsibility into algorithm development. At a recent event at Google, FTC Commissioner Gerald McSweeney discusses, and so the FTC has talked about things like security by design and privacy by design. She also proposed, responsibility by design. Basically, a company needs to be able to test its algorithms for bias. How does that actually happen? So that, should a company want to self-police and ensure that they're not discriminating against on race or on gender or anything like that? How does a company actually systematically evaluate its own processes to ensure that it's acting in good faith?
It's a complicated question. So first of all, I think there needs to be a clear outline of what the risks are, what the sort of sensitivities are in a given algorithmic application, whether you're dealing with potential bias based on vulnerable categories that go into, let's say, credit lending decision making. Then you have to look at how the algorithms are actually working. I think there's a sort of surface layer evaluation where you can look at the algorithm and say, this algorithm is making predictions based on factors X, Y, and Z. Those are factors that I understand not to implicate sensitive categories, and therefore I've mitigated most of the risk. On the surface, that may be sufficient, but in reality that often isn't sufficient, because you run the risk of, for example, using proxy measures that point at sensitive categories. So a good example of this is so race is a sensitive category, but zip code is oftentimes a good proxy measure for race or ethnicity, because ethnic communities tend to cluster in given geographical locations. So then you have to ask yourself questions around, in the development of these algorithms, are we implicating factors that may involve these sensitive categories through indirect means? And that's a hard determination to make, not mathematically, not computationally, but in terms of policy, because you can essentially create a sort of correlative regime where you look at the correlation between these potentially discriminatory outcomes and the factors that you fed into your algorithm, but you have to come up with some notion of a threshold. What are the weightings above which I've started to create risks that my algorithm is producing discriminatory outcomes? And that's ultimately a policy question. So it turns to this point of, I think companies can create, or corporations can create, regimes for algorithmic oversight that produce the outputs that are critical for making those determinations, but there has to be some level of policy engagement for determining what are the appropriate tolerances that society is willing to adopt for given applications.
Sure. If I could just make a point, you had an interesting change of terminology at the end of your question. You stopped saying algorithms and you said processes. And so if we said everything that you just said, replacing algorithms with processes, we would be talking about human relation, right? HR. And all the watchings for bias and things like that people perhaps would manually do. And so the transition to algorithms is just using computer systems to more automatically, I would hope more efficiently, do many of those things. But again, absolutely watching out for the bias is critically important. So that's important to remember, is that a lot of these algorithms are simply replacing human, more manual processes. And if there were inherent problems in the human processes, there could be those problems in the algorithms. That's not the fault of the algorithm, it's the fault of the human, right, as it goes back to it. And we certainly have to be careful, no question about that. But it's not, algorithms don't, by themselves, do these things.
Yeah, I just want to actually build on things that both Bob and Courtney have said, which is that algorithms are neither bad nor good, nor are they neutral, right? And so precisely this idea of an algorithm as automating a process, an algorithm is essentially, like you were saying, it's a recipe, right? And if you know how to do the recipe based on history, right, whatever was in, if you're learning your lessons from the past, in this case, then that's how you'll proceed in the future. So, for instance, if your training data is in some way biased, your algorithm will be biased. So, it's, I think, a question of each. In the question of responsibility, it's in thinking about all of the kind of ingredients that go into the algorithm and ensuring that you have the best data set that you can, and a historical data set that is not, it would be difficult to find a data set that is not biased, but sort of accounting for the bias that might be inherent in the data that you're training on. And then also, Bob, when you were speaking about the specificity, I think that that's another example where when we talk about responsibility in a meaningful way, we probably do have to get down to as low a common denominator as bad metaphor. It's probably very specific to the kind of industry that we're focusing on, right? Because responsibility is going to mean something. It probably is going to mean something different if we want to talk about like transportation, where it's always life or death, versus in sort of I don't know, PR or marketing algorithms, right?
Do you want to just expand on training data? I'm not sure everybody understands how training data fits into it.
Please, you.
Oh, okay.
I'm a visitor in this land.
Okay, so training data is often used in this area called machine learning, which is kind of a cryptic term. But basically, you are looking at a subset of historical data. And when you develop your algorithms or your learning algorithms, you're trying to use that to help understand how you should predict what happens in the future, right? So you take a portion of your historical data and then you train your algorithm, you say this seems to be working. And then you look at another portion of your historical data, but now understanding, did your algorithm correctly predict what happened, right? And then if it did a good job there, right, and oftentimes you do this, you switch up the training data just to really try to get some accuracy. You at least have some greater confidence that the patterns you've seen in the past are going to if you see them in the future, okay, your algorithm will work. Now where does this affect you? If you are a Netflix customer, if you are an Amazon Prime customer, if you are any sort of music streaming customer, where it is making recommendations. Right? They're called recommendation engines, they're algorithms, because they will look at your previous behavior, maybe how you've rated some music, perhaps people like you who like the same sort of music, to make predictions in the future. So that old data that they use could be the training data in order to fine-tune how they make the recommendations for you. And then you can expand to other applications.
Right, and so, even 90% accuracy, 80% accuracy is good enough in those contexts,
right.
But it's not good enough for anything that sort of involves transportation, for instance.
Or making that autopilot decision.
Or making,
in
right.
a split second. Right.
So what is good enough, I think, is a...
I agree. I don't know how society will ever determine what's good enough for a decision of whether or not a self-driving car can be programmed to kill. It's a decision that will have to be made at some point, whether you swerve out of the way of 10 people to hit one person, or you swerve out of the crowd to kill the driver. That is a really tricky moral and legal question, and I don't know if anyone in this room can figure out the answer. But I think what's important to remember is that no matter what the outcome of that decision is, that is a net benefit regardless, because of relying on self-driving cars increasingly. The amount of people dying in traffic accidents is going to plummet dramatically. And that's what I think it gets left out of this conversation a lot, is that every time someone rear-ends one of Google's self-driving cars, or every time this ethical dilemma gets brought up, that is just a balance that's not there. And that these are really important questions that we need to figure out. But we also need to keep in mind that this is the direction of progress, and this is what we have to aim for, not just let's hesitate on self-driving cars, because that is basically going to be more people will be dying that way, and it's kind of weird to put it bluntly like that. But so going off your recipe example, that I really like that analogy, but recipes are static, right? Whereas with machine learning, algorithms will be dynamic. They'll be constantly learning. They'll be constantly refitting themselves. They'll be training themselves on new data to optimize their own outcome. But as we mentioned, there are two opportunities where discrimination could occur that I've at least identified. There are unintended biases based on inferring data that they didn't think was sensitive, or just outcomes that have a disparate impact that objectively shouldn't be there. Or it's trained on historical data from when humans ran the show, and those, it's learning from human decisions, and those human decisions were biased. So how do we kind of encourage businesses, governments, schools, hospitals, what have you, to kind of adopt a much more dynamic approach in algorithm development, so that it's not just learning from how humans operate, because that, as we know, is fundamentally flawed. How do we kind of get to that next level of removing bias? Is it just an education issue? Is it a technology problem?
Let me just correct. I don't know how much you cook, Josh.
I like to think I'm all right, but sure.
You know where it says add salt to taste?
Yeah, that's true.
That's not quite quite so deterministic. No, actually, but though people who are chefs do adjust recipes all the time for various reasons, right? So maybe what's printed initially is static, but the actual recipe will change over time, and could change by the human given feedback, saying, hey, if you're a customer, you go to restaurant, say that really did have too much salt. Well, that might be adjusted. So I just want to make that not making this a cooking panel. I'm trying not to let it, but
I think there's. I don't think I'm going to directly answer your question, but I think it's important to hit on a point that regardless of how willing you are to absorb the capacity of algorithms to make decisions as part of a natural progression or an important progression in society, there are risks in sort of letting the algorithm go free and conquer a domain. Specifically in biases that may have been addressed at the early stages in terms of creating as objective as possible of a training data set to generate the initial algorithmic output, and then over time creating an algorithm that you think has eliminated most of the problematic factors. there are still risks of very subtle biases creeping up and reinforcing over time. That sort of feedback loop of generating outputs that enforce the outcomes of the algorithm, particularly in economic contexts where I think there's been a lot of concern that's been expressed in a lot of the algorithmic discourse coming out of the White House and other government sectors about this new regime of algorithm reintroducing civil rights issues that around redlining and other sorts of risks that have been dealt with in prior civil rights legislation. Those are real issues in terms of how the algorithms might, over time, particularly in machine learning contexts, subtly replicate historical concerns. And as the data comes in, as people are pushed out of given marketplaces, and the algorithms continue to create a corpus of information around a more and more select group of society, that more select group of society is going to produce additional machine learning outcomes or algorithmic results that are just going to compound those issues. So there needs to be some measure, I think, of oversight in terms of how those outcomes develop over time. And I guess this gets more directly at your question, having that some mechanism in place for different disciplines, different jurisdictions, to see how the algorithms are developing, particularly when you're dealing with non-deterministic algorithms that aren't well established in terms of fixed weightings up front, but are going to evolve as new inputs are brought in. Having some way of sort of to continue on the cooking metaphor, step in and taste the soup occasionally and understand what's actually happening with the algorithm.
I'm going to push the cooking metaphor one step further and say that, also we have to cook every day. It needs to be an ongoing process. And so I think there's in some business literature, maybe there's a sense that if we bring in this algorithm to automate this process, it's done, we're over, right? We've taken care of a problem. And I think what we end up seeing in practice is that it doesn't automatically replace someone. It changes how they do their work, and it also is an evolving process within the organization, and someone needs to be paying attention to how it's unfolding. So it isn't just a quick replace a part and then you never have to look at it again.
But one element we haven't mentioned here, by the way, is we've talked a little bit about data, we've talked about algorithms. There's a notion of a model in all of this. And so, model is pervasive through all of this. It's pervasive through science. How do you model chemical reactions, right? There's a lot of differential equations. But when you have data, basically you are setting up a series of equations that relate various factors of what's going on. Certainly economics has been doing this for hundreds of years, and in all the physical things we talk about as well. Now, if you forget certain variables, like temperature, right, your model will not accurately reflect over time what is going on. And it is really this model with the data that feeds into it, and then the algorithms which work within the constraints of that model of what we're talking about. So if you model a situation incorrectly, just by whatever, either forgetting variables or having variables that are actually dependent upon each other instead of being independent, lots of mathematical concepts, then you'll be wrong. And so much of what we're talking about is not just tuning the computation, it's tuning the model. How accurately does it reflect? So in the Netflix example, you may be adding more features. You may be adding who are the actors or actresses in this, right? Not just whether it's a comedy or a drama and things like this. So your model is getting more and more refined about what are the aspects of movies that really affect people. And in the same way, the model of a self-driving car, is it taking into account the weather? Is it taking into account the wear on the tires? Is it taking into like this?
And
so
the
it's
changing infrastructure on which the car is driving.
That's right, the potholes. And it's all these factors that lead into it. And this is what we're trying to do the best possible job, right, of doing the model and then doing the best possible bug-free computations to either drive that car safely with the people inside or produce the best souffle or whatever.
So I'd like to point out that IBM's Watson does have a cookbook, so that was some very subtle product placement.
That came from my group, actually.
Yeah, it's actually pretty good. But I just want to push back a little bit because you're quantifying these human processes that could necessarily, ingrain biases. But the act of quantifying that process then gives you a valuable opportunity to actually analyze these human processes that you've never really been able to test before. They haven't been logged, they happen in back rooms, they happen completely subjectively. And so what I'd like to see is, businesses and company and governments and schools and medical schools that make admissions decisions or hospitals that do have organ matching algorithms to turn the algorithm on itself. Basically, you now have this opportunity to use algorithmic decision making, to expose biases that you could never really measure before. We've seen that CFPB just handed down in 2013 one of the largest auto loan discrimination suits in history because they used an algorithm to identify the race of minority borrowers of a company called Ally Financial that couldn't legally collect information on race to make crediting decisions. But it turns out their subjective decisions, their human in the loop part of that equation, was unfairly discriminating against hundreds of thousands of minority borrowers. So I just want to, yes, algorithms can reinforce biases, but it's also an incredibly valuable opportunity to expose biases because you're automating these processes. Then you get that new kind of insight, and that's how you can more effectively fit the model to accommodate for those new factors. So going off of that. Predictive policing is a very hot topic, and I know, Courtney, this is something that you've worked on and discussed before. And every time algorithms get brought up in this discussion, in this context, Minority Report invariably comes to mind. And people are afraid that algorithms will necessarily be used to circumvent due process, to arrest people before they commit a crime is what the fear distills down to. But in reality, it's quantifying policing practices that they could never really measure and aggregate and do trend analysis over time before to identify hotspots to place officers more effectively. So how have you seen police departments use this to augment policing capacity rather than circumvent a legal system? Or are there safeguards that they need to consider in that process?
Yeah, I think there's generally two broad areas of application of predictive policing regimes, and then there's a whole set of mythology around what predictive policing actually is. I was at a conference several weeks ago at which an academic was presenting on predictive policing, and she spent literally the first half of her talk recounting the synopsis of Minority Report, followed by a little bit of substance afterwards. But it's unfortunate that I think there's a lot of misunderstanding about what predictive policing actually means in practice. So the two general types of applications of predictive policing are sort of focused on target evaluations. So identifying based on profiling information individual targets or suspects for investigative leads. The other camp of predictive policing deals more with behavioral patterns, things like near repeat models that look at environmental factors that tend to lead to specific criminal activities and therefore create more refined applications of hotspot mapping. Because if you can identify the factors, the environmental factors that are likely to lead to certain types of criminal violations, you can create or you can make smart resource allocation decisions and push your limited policing resources to the right locations at the right time, and so forth. I think if you start to break down this regime of predictive policing into those two camps, you can get at some of the associated risks. When you're talking about targeting individuals, I think generally you're dealing with a domain that's much more problematic because you're necessarily looking at individual attributes, and that is likely to produce, whether intentionally or unintentionally or indirectly, sensitive factors that implicate civil liberties issues in particular. So a lot of the predictive policing regimes that we've seen, not that we've deployed directly, but that we've seen in the marketplace that focus on these sort of targeted models, tend to be deeply problematic and also very ineffective. I tend to see more effective results looking at these sort of refinement models where there's a clear causal explanation of what it is about given environmental circumstances, historical patterns, that can generate smart predictions about when criminal activity, criminal behavior is likely to happen, and then make smart decisions in terms of putting the cops in the right spots at the right time.
So, and this relates to policing because obviously, the discourse in this country is very much that racial sensitivities in policing, that there's widespread allegations of discrimination, of unfair practices, basically because police have been operating when their actions aren't always logged by an algorithm that may be changing as we get at body cameras and other things and wearable sensors where we can track officers, things like that. But it strikes me as an opportunity that this discrimination has been allowed to occur, not just in policing, but in lending, in finance, in healthcare, and education, because at some level, for a long time, creditors, for example, could not legally collect information about race, and there was a good reason for that. I think when the law was passed in the 1970s, that you can't factor these subjective qualities into a financial decision that could affect a consumer. But now that we have systems where we can essentially in real time monitor every decision being made, log information about a consumer, and automatically detect when a problem might arise, do we need to rethink how we collect this kind of sensitive information where there was once a good reason for it, but now we can kind of shed much more light on what's actually going on? Are we sacrificing a valuable opportunity by not collecting this information?
Yeah, I think your point now and earlier when you were speaking more directly about the credit loaning situation is a great one. I think the ability to police these predictive algorithms or predictive regimes really gets to a question of infrastructure. Do you have the appropriate infrastructure to be able to interrogate the models later on down the road and facilitate questions around public redress? Was a person arrested because a predictive algorithm made some prediction that may have implicated sensitive categories that shouldn't have been involved in that prediction? The only way you can answer that question is if you have a data trail that points to the decision that was made at a given point in time, or gives you some understanding or insight into how that predictive algorithm makes its predictions and the data that feeds into that. So you have to make some decisions around what sort of data you're going to collect and how you're going to expose that data. And then you have to figure out a smart way of producing that information, making it responsive to requests in the public and to the community. And that's actually a tricky question because in the credit in the credit sphere, we've had environments for a long time in which individuals who are issued credit can make a request for their credit scores and try and understand how this credit determinations are being evaluated. But the reality is that very few people actually make those requests, and that may be a function of it being difficult to make those requests, or the way that information is being presented isn't entirely transparent or easy to infer. So you have to come up with some sort of mechanism for making that information more accessible. And the more complicated your algorithms are, the harder it is to make sense out of that information. But I think that the net benefit to society is in being able to provide that sort of audit information to help understand how the algorithms are working over time, and then come up with a sensible regime for exposing that information subject to appropriate inquiry. And that gets into all sorts of questions around how broadly you are willing to expose that information in response to things like FOIA requests or Public Records Act requests. What are the sensitivities of personal information implicated in exposing broad sets of data that may be easily identifiable or re-identifiable? But those are things that are technical challenges that can be resolved. But I think overall there is a lot of value in tracking how the algorithms are working and providing some mechanism for recourse and redress later on down the road when the algorithms seem to go haywire, so that you can make an appropriate determination.
Okay.
Can I just add?
Yeah, and then, so really quick, and then I'll have one more question, and then we'll go to audience Q&A. So
I want to say that I do fundamentally agree that having the ability to more precisely see what's going on in these processes through examining the algorithms provides a really amazing opportunity. That said, I think that the idea that just because something is transparent means that it is free of discrimination, which I know is a caricature of what you're saying, but I think that is a theme that we hear around transparency, that because we can look at it, we can know about it. And I think it's important to keep in mind how discrimination is systematic. It's not, or it's systemic. It's systematic, but it's also systemic. And it's not in the data, it's in the model. And just because we can see what's going on doesn't make it automatically okay. We need to use that transparency in a specific way and also understand what are the limitations on what we can see. So I know that police body cams are not exactly the topic of this panel, but they present a really, really interesting way in which, at first, body cams seem like a fantastic idea, right? You can actually see what's going on. But if we look at, historically, the way in which videos have been used, and we look at social science around what it means to see a video as evidence of something, there are limitations because the way that we perceive is embedded in our larger kind of social beliefs, right? So it really depends on from where you're standing, literally and also figuratively, what you can see in a video. So that's just an example of, body cams does not equal better policing.
Sure. And then so, Madeline, you talked about this in the beginning, and then I want to bring Bob, you back in as well. So you talked about how, just as algorithms can remove humans from the loop, or can remove opportunities for humans to make decisions, they can also, or we also should consider how they can also contribute in new ways that weren't possible before. So healthcare comes to mind, is that Watson is used at the VA to make healthcare recommendations, and then the doctor acts on that information. Whereas 10 years ago it might have been an almost entirely human-dependent process. So where are there new opportunities where we can kind of rethink human-machine interaction, and so that ultimately have better outcomes, but we're not fundamentally doubting the reliability of these algorithms? How do we kind of push that next level of accuracy and efficiency?
So some of these things, such as Watson, tend to excel where there's just a huge amount of a huge number of documents. So the number of scientific journals that are published in any given year, whether it's medical or any of the other fields, is more than any one expert can read, right? And that's just a key problem. And so these systems that can absorb this and perhaps either abstract it or ultimately be able to reason in it, in the sense of being able to ask a question. A lot of these are question answering systems. Has anyone ever done this? Has there been a situation like this? Has someone responded well to this sort of treatment, or in fact education, right? Can we help someone learn better by doing this type of thing? So one aspect of these systems is simply to get control of all the data that's out there, in this case textual data. And so that replicates it, not just healthcare, but many other fields. I mean, the legal fields, the policy fields. I mean, does anyone here read every single policy document that concerns one's field? It's just impossible after a while. So it becomes more of a super librarian for you in that way. And so that is a major benefit. Oftentimes these things provide benefit just because of speed, right? So algorithms, particularly local algorithms, versus going off to the cloud, can respond much faster than a human can actually respond. So we're talking about self-driving cars. You may want your car to tell you, well, you're going through a state park. I don't have maps. Here, you drive. Okay, nice. As opposed to, there's a deer, steer, right? I mean, there's a fundamental difference there of what you're trying to do. So there are lots of these situations. I think you fundamentally want to think about how any of these systems can augment human behavior, right? I mean, that's first and foremost how we need to be thinking about it, either because of the volume of data or the speed or any of these sorts of things. And just the final point I wanted to make, which came up a little bit, is the notion of auditing. And so we've talked about kind of around this notion of making sure they do the right thing. Human processes get audited. The IRS audits human processes of a sort, right? In the same way, you perhaps should have systems that audit the result of what algorithms are producing. Now, from a computer science perspective, we don't use that term audit. We use testing, right? You actually, with certain given inputs, are you getting the right outputs? Now, it becomes more complicated when algorithms are learning, but nevertheless, are you producing perhaps biased results from given inputs? You should have systems that are looking for that as well, because humans may not always be able to detect that so easily. So systems can work with systems, which can work with systems.
Sure. Yeah.
Yeah, just wanted to add about this idea of augmentation. I think that really is the way that we can think about effectively making these systems and systems of systems really actually do make our life, how they can make our lives better. And I was speaking with someone at GE who had this fantastic idea. It's his idea, so I don't want to plug GE. I want to plug him. And he was talking about this idea of automating work in a factory and algorithmic augmentation of a human work, and seeing it really as this idea about how to add value, how to understand what is it that the user as well as the company sees as the value added. So if you introduce a process and say, this is going to make your job easier, someone is going to probably resist that, because if your job is easier, then eventually you will be gone, right? How do I help you do your job better? That's how do I help you add more value to the company? It is the same thing, but it's differently worded, and I think that's a really important perspective on thinking about augmentation.
Sure. All right, so we're going to turn it over to audience Q&A. Feel free to raise your hand, and you'll just have to yell and project, and then we'll also be fielding some questions from Twitter as well. So, and then also please, say your name and your organization, and then go to your question. So, yep.
I'm Stuart Ridgway. I'm with the International Trade Administration. So you mentioned using the algorithms to expose biases,
yep,
which I think is a really interesting idea. So how do you recognize them when you see them?
That's an interesting question, and someone who, I just spoke to someone about this from the ACLU yesterday or last week for about an hour, that may be able to answer your question a little bit more specifically. But the point is, we can, automate our tests for disparate impact. We can use algorithms to process massive amounts of data on consumer transactions, factoring in I don't know how many, facts about their race, where they live, their ethnicity, their age, that we just could never really do before. So, it would be a manual process. It would be much more time consuming, and it wouldn't be nearly as comprehensive. So, it's basically another tool at consumer advocates' disposal to, algorithms can also protect against this bias. They can reveal things that humans can never really see before. So the CFPB example I discussed, we actually just wrote an article about that on the back table. It inferred Ally Financial customers' race and ethnicity based on their area code, which is what Courtney mentioned, and their last name, which proved to be, for a surprisingly simple test, it was pretty much 95% accurate for almost every ethnicity that it examined. And that's just an opportunity where, to identify bias in this situation before, say 10 years ago or 15 years ago, that would have been impossible to do. And a big criticism of the indirect auto financing industry, which is what Ally Financial was doing, was that Ally Financial could say, all right, our algorithm that produces a buy rate for auto dealers is an objective assessment because they can't collect information on race. So it's things like their credit score and their objective factors that indicate their willingness to pay. But then at the dealership, there's a completely subjective window where the dealer can mark up prices however they wanted to capture more profits. There was no algorithmic decision making at that point, and that's where the discrimination occurred. So we would like other regulators, and that's one of the things I was hoping Greg could add to this conversation as an environmental regulatory agency, is to kind of understand how we can follow in CFPB's footsteps and use the same technology to expose human bias where we can never really even detect it before. And so, I'm happy to discuss after you. There's a couple other examples like that. Okay. And then feel free if anyone wants to add. So.
Yeah, I think it's a great point. Just in the same way that data analysis and sort of algorithmic inquiry can start to expose bias inherent in manual decision making historically, you can also treat algorithms that are proprietary algorithms within organizations as the black box that they seem to be, and then look at correlations with factors that you associate with sensitive categories that implicate bias. And then the point that I was trying to make earlier, the question is really, what are your tolerances for specific factors? So you may find that you have weightings that are non-negligible, non-zero, that point to some implication of a bias factor, but maybe it's not significant enough. And that's kind of a policy question that needs some resolution. Are you willing to allow some sensitive categories to creep in to some degree? And then to what degree are you willing to allow before it becomes deeply problematic?
Anyone else? Yeah.
Can you foresee institutionalization of this algorithmic oversight? Certainly in drug approvals, there is a whole system of clinical trials, numbers of populations. Can you see something like that happening with algorithms? Sorry, I'm Barbara Jasny from Science Magazine.
I have some thoughts, but I'll let you guys take it first.
I'll take a stab at that. I think it's not unreasonable. I think in the absence of self-regulation, we are likely to see third-party entities, not just sort of as a necessity, providing this type of algorithmic oversight, because there are a lot of proprietary issues in the way the algorithms work, and kind of cracking open that machine and exposing all of the intricate workings of how a given model might function is a really hard question to do. And even if you could do it, it's not clear that you would be able to derive very clear deterministic insights that would point to policy decisions. And so in the absence of that, I think it's very likely that in certain domains we may turn to third-party entities that are provided with some set of information relative to the outcomes of those algorithmic decision-making processes, and they're tasked with this remit of determining whether those outcomes are biased or in other ways problematic. Whether that's a legislated outcome or whether that's something that industries agree to because they realize that maybe there's competitive virtue for having some degree of oversight and accountability that they can point to as opposed to pointing to some literature that they produce in-house, I think is an open question. But in terms of addressing the general question of public trust around algorithms and whether algorithms are these scary things or whether they're actually creating net welfare benefits, public welfare benefits, I think you almost have to turn to a model where there's some sort of third-party independent oversight over how the algorithms are used.
I would just caution again about overgeneralization of this term algorithm. Everything is an algorithm. Everything you do all day long is an algorithm. So I would ask back to you, an algorithm that does what? In what field? With what goal? Right? And by the way, it's not one algorithm, it's a set of things that are working together. So really be very cautious about just tossing this word algorithm around as being a class of great big things that, any particular area, right? So an algorithm to do what in what specific field for what specific goal. And then if you want to get extra credit, is it a machine learning algorithm, is it any of these other types of things?
I just wanted to kind of throw in another question, I guess, that we at the Intelligence and Autonomy Initiative are thinking about, which is if there was to be some kind of third party or legislative oversight, should that fall within kind of each industry, or should it be cross industry? Because a lot of while the model may be specific to the industry, the kind of fundamentals of how to make that model may be cross-industry. So it's something that we're kind of thinking about, because I think there isn't a clear answer just yet.
And so I wanted to just real quick, in terms of actual, drug testing. So we put out a report a couple years ago called "The Rise of Data Poverty in America," and we found that women and minorities are dramatically underrepresented in clinical trials. And when that happens, we have instances of drugs being tested on like a primarily white male study group and then being approved. They found very low risk of any side effects. And then it was later pulled off the market because as the general population took this drug, we know that women react differently to drugs than men do in certain cases. We know that certain minority groups react differently than majority groups do to certain drugs in certain cases. The problem there is that the approval process was made based on human analysis of what they thought was a representative sample. If you introduce more algorithms to the equation that can kind of weight these factors differently than just manual analysis could, then I think we'd have a really interesting opportunity to prevent this kind of discrimination, but it's a weird form of discrimination that we don't see in a lot of other fields, that we can ensure that our models can factor in missing representation. And this, I'm speaking as a policy person, not as someone who designs algorithms, so maybe Bob can back me up. But this is a problem that has always existed in the drug approval space. And I think this is an opportunity to make sure that drugs are safer and the testing mechanisms are more equitable.
And it's a classic problem with statistical sampling.
Sure.
Right. I mean, going back 300 or 400 years. Right.
Sure.
You pick the wrong sample, unless you're going to ask everyone in the country,
Right.
which you're not doing. How do you choose the sample? And that's just a classic problem. And lots of things have been done for a long time around that. So.
In the back.
Neil Chilson, I work for Commissioner Olhausen at the Federal Trade Commission. Maybe addressing something that Bob mentioned and then kind of tying in the idea of oversight. I know yesterday Google, maybe it was 2 days ago, Google open sourced their TensorFlow AI software. And one of the articles I read talked about the fact that this is a good move for Google because they're open sourcing this sort of, the algorithm, but the data is what really makes this thing powerful, and they have that. And to Bob's point, if we're going to have oversight and transparency about the algorithm, but it's the data that really is the fuel to that makes, and especially in the machine learning place, where you can look at a decision tree algorithm, you can see how the algorithm works, but unless you have unless you've run and built the model, you can't actually see what the outcomes would be using that algorithm. How would we do oversight where the algorithm and the data are so intertwined that it's really hard to separate them in a practical way without getting, whoever's doing the oversight, whether it's if it's a government organization, how are you going to get them that involved in the process where they're having to not just look at the algorithm, but then the data as well, and sort of way to sample that. I just see some practical problems there. What would your guys' thoughts on how you do oversight in algorithms that change so fast?
I'll try to answer. Yeah, I agree. It's a hard problem, and I think you hit on the crux of the issue that transparency in the inner machinery of the algorithm alone is not sufficient. You also have to have some understanding about the data itself, particularly the data that's been used to train a model, because that's going to determine the actual model parameters, the factors that determine actual outcomes. There are some sort of readily approachable mechanisms for dealing with that. You can attempt to de-identify a data set and expose it to a third-party entity and provide them with a clear outline of the algorithm or the algorithm itself or the model itself, and let them kind of play around with it and see if they can reproduce outcomes. I think there's going to be a lot of reluctance to do that unless you have kind of clear terms of engagement with the oversight authority, that they're not going to they're going to handle the data securely, that they're not going to repurpose it, that they're not going to introduce any other worries or concerns that are going to violate presumptive measures and how that data was collected, and the user agreements that were involved in that data collection. Those are real significant material concerns. You can get around them a little bit through de-identification, but it's also very easy, we know from the literature, to re-identify data, so there's other concerns there. I think we have to look at ways of sort of independent oversight that almost looks at parallel regimes, where we're relying purely on the outcomes of these models and almost treating them as black boxes, and then evaluating those outcomes to understand whether the outcomes themselves, based on generally agreed upon notions of discrimination or bias, are producing those biases. I think there are statistical ways of approaching those sorts of questions. They may undermine a lot of the nuance of the algorithm, and the computer scientists who develop those algorithms may cringe at that thought. But I think in practical terms, that may be one of the only ways of really methodically and broadly being able to approach that question.
I think at some point, when you get to these discussions, you have to look at the architecture of the system that you have in mind. And here I don't mean the very, very low architecture. I'm thinking of the one PowerPoint slide with lots of boxes stacked on top of each other, right? Where typically the things at the bottom are the most basic, and the things at the top are very specific to the area in which you're working. So be it drug testing, be it education, be it your car, whatever. And down toward the bottom, you have a lot of very general purpose technology. You could have the network, you could have computers, right? And as you go up, it gets more specific, and you might have particular software, whether it's AI software, neural networks, things like this. But at some point, the specific data comes in, right? So it's really not a jumble all in there. The pieces are separated, at least theoretically, into these nice boxes. And understanding the layers, right, is very significant, because there are general purpose algorithms everywhere throughout that. But zooming in on the place of your concern, right, lets you understand how the pieces relate to each other, the computational aspects, as well as the different type of data, the different types of data input, how the data is curated, what's done with it, and so forth. So to get a good view of what's happening, you have to at least see that, and then ask your questions about whatever box you may be interested in, and of course the final result.
Sure. Other questions? A question from Twitter.
A question from Twitter. If we automate critical decisions, are we creating a cyber vulnerability that humans don't have?
Yeah. I mean, the more you create the potential of displacing human decision making, particularly when you're dealing with questions of moral culpability. Absolutely, there's a risk that, regardless, there's a risk that there's cybersecurity factors that come into play, that the system could be hacked, that the data could be hacked, the model itself could be hacked, and therefore the outcomes could be gamed or hacked or invalidated or exploited in some way. Obviously, I think those questions and concerns become even more acute when you're talking about decision making that implicates the lives and well-being of individuals. And so for those types of regimes, you have to be even more studious and careful about how those actually play out and the decisions, whether you're willing to accept those tolerances and whether you have the appropriate fail-safes in place to ensure that maybe there's an additional degree of checks and balances that happen before the machine goes out and enacts some outcome that could potentially be detrimental. This gets tricky in the domain of sort of immediate or real-time events like this. You think about the decision making that may happen with the self-driving car and the algorithm that determines whether you hit in an emergency scenario, you run off the road or you run into another car. There's a potential that machine could be hacked, and there's some scary outcomes that could happen there. I don't have a good answer about how you deal with those questions or where the culpability lies, whether that's something that gets pushed to the algorithm developers, whether there's something in the IT infrastructure that needs to be held accountable in terms of addressing all of those cybersecurity risks. whether there's a pooled risk of that's associated with all of the parts of that architecture. Those are really hard questions that I think we're going to see play out over the course of the next 5 to 10 years.
You have to design with security first, right? So neither security nor privacy are afterthoughts, right? So you have to begin to do that. So while these systems could have vulnerabilities, and oftentimes they have vulnerabilities because they have the wrong security model, or there's just a bug. The person made a bug, right? The technology should have worked right if it had been implemented correctly. I will also say every single day, thousands of people click on that link in that suspicious email and go to some site and very happily give them their password, right? That is the social engineering aspect as well. So this is one big collection of the same problem, different aspects of it.
I saw you first, and then one more question, and then that should be all the time we have.
Hi, I'm Elizabeth Grossman with Microsoft Tech and Civic Engagement. And I wanted to sort of shift a little bit. We talk a lot about underlying biases that come from the data or somewhere, and in some sense, those are unintended bias. We aren't actively seeking to replicate our past historical flaws, but they happen. But also, as we think about the design of the algorithm, to pick up a word that was just used, we also have to think about algorithms are designed to optimize. And they're designed to optimize for different goals. And I'll give an example of an algorithm that's in the real world now that I think the federal government has struggled a little in oversight for, which is high-frequency trading. So that's an algorithm. It's out there. It's being used. It is operating faster than you could possibly have a human in it. Right? That ship has sailed. The time scales, our brains, our neurons don't work that fast. So there are a couple of questions here, which is when I'm seeing those, the performance of those algorithms could be optimized, and I'll just give 2 examples. One is they could be optimized to make money for the people running them. But another thing that goes on in markets is there is a discussion around whether those algorithms are helpful in stabilizing markets and creating markets. Those are 2 different ways that you could design your algorithm, because you can't always design an algorithm that optimizes for everything you might want to accomplish, right? And so access to auto credit and making sure everyone is treated exactly the same are not exactly equal in the optimization. So I guess I'd like to think a little bit and hear people's reactions of when you're thinking about algorithms, how do you optimize for what is acceptable intent, and then how do you make sure your algorithms are designed for that intent? And that's a policy and a technology question. And a human trust question.
I think also the Volkswagen code is another example of not just optimized for different actors. Like that was great for Volkswagen while it was going, but also how, and this is another part of the security question actually, what are ways to hide code within code? So, I mean, I don't know what the right answer is. I'd be curious to hear what the other panelists think. It seems to me that, the first step is just to, again, acknowledge that these algorithms are not neutral and that they are furthering human interests that are embedded within the humans from which they emerge. And then that, I begin to think, is that where we need kind of third-party oversight in some way to be sure that consumers are not being taken advantage of along with FTC works?
I think, so your point's a really good one, and it dovetails with one of the guiding principles that I laid out initially, this question around scope. And refining the purpose and intent of algorithmic design. And I'll use the example of predictive policing because I think there's a very salient example there. A lot of the predictive policing work that's been done to date, not necessarily in my company, but in other companies in this domain, have looked at certain classes of predictive capacity with respect to certain types of crimes. So, for example, property crimes, it turns out, are relative. The algorithms are relatively good at making these predictions because their underlying environmental factors, like lack of outdoor lighting, creates propensity for crooks to break into shops or whatever. And there's a good story you can tell about why that happens. But when you try and morph those predictive regimes to, for example, crimes of passion, there's a breakdown, because these algorithms are in their design and implementation, there's a tendentious element to how they should be used and how they can be used. But when you try and affect that scope creep, you run into real issues. So you do have to think about how you're starting off with these optimization questions, how you're determining what the scope is, and there needs to be some either self-regulatory attempt or external regulatory attempt to ensure that you're not overstepping the bounds of applicability of the application of the algorithm. That's maybe a question of discipline. It's maybe a question of oversight.
So we're going to try to squeeze in 2 more questions. Yep.
This is kind of an observation of extension of the discussion. I'm Jim Ederman with the National Association of State Workforce Agencies. Our members run workforce programs and unemployment insurance. And I spend most of my days these days worrying about fraud and overpayment with unemployment insurance, which runs multiple billions of dollars a year. But one of the things, we have lots of algorithms to find out who the fraudsters are or who the employers are who may be not paying proper taxes. But one of the interesting things we're working on right now is an algorithm for folks who may have an overpayment. And so a lot of you, if you go back to work and you've been working, let's say, for 2 weeks and you don't get your check till the 3rd week, and you say, well, gee, I'm not employed till my 3rd week check comes, but you've been employed for 2 weeks, you've actually drawn 2 weeks of overpayments, and that's not proper. But one of the things we're doing is trying to identify folks who have that characteristic, and then we're using behavioral economics to change the message to them, so when they come on board to certify for their week of unemployment, we go back to an algorithm and say, well, it's highly likely this person may have actually really got back to work. So a message will come up and say, are you sure, that you really didn't go back to work? Or another message will come up and say, 5 of the 6 people in your neighborhood correctly reported this on their last unemployment insurance check. We're finding that it's having a fairly large impact on the behavior of the individuals who are filing, because the message is changing based on an algorithm that says they're highly likely to have been in an overpayment status. So it's kind of interesting distinction, which may lead us to some biases down the road or something we'll have to take a look at. Just more of a comment than a thing. But it's just
That's a really interesting example. Any comments?
Just somewhat related. So people have been doing psychological profiles, for example, based on tweets. Okay? And there are a range. In the psychological literature, there's something called OCEAN, which defines the different types of person you may be, outgoing, things like this. My favorite is neurotic, which basically means fussy. Now, in call center uses, this is really useful, because we've all called call centers, and some of us are very calm, and some of us are on warpaths, right? But to match the right person calling in to the right person at the other end of the phone to get the right human response, ultimately, of working through the problem can be very, very important, right? And it's done with fairly neutral terms, but it's simply to optimize, in this case, the customer engagement, right, to make sure that whatever the problem is, it gets resolved quickly by a sympathetic person in the shortest amount of time. So, yes.
Relevance of call centers too.
I think also, just to quickly add, that's a really beautiful example, I think, of how an algorithm can help an organization see the larger holistic picture, right? So people drawing on, it sounds like, and from research that I've read, drawing on unemployment isn't necessarily just a function of if you can or cannot go to work, right? There are all these other factors. And so that sounds like a great way to kind of see the larger picture.
Nudge them along.
Yeah.
All right, and our final question. Yep.
Okay. My name is Martin. I'm the scientific attaché at the French Embassy. And I was wondering, the way that society can use algorithms to make better choices is really different from the way that society can use humans to make better choices. And if you think about human, you have to deal with validation, you have to deal with collaboration, with a way to control the process, about the quality, about the context, many different things. And so the question is, do you think it's really different to deal with algorithm for this purpose than for human?
So I just want to say, I think that I would sort of take issue in a way with the framing and say that we're actually quite far from having a discussion about algorithms over here and humans over here, right? We need to think about the ways in which maybe human plus algorithm is different than human, but that there's a human, even if it feels difficult to kind of see, right, there's still a really strong human infrastructure that needs to be around the implementation of every algorithmic system at like a meaningful level. So that would sort of be my comment, that I think maybe what we need to think about is that kind of human and algorithm connection and how to make that augmentation stronger.
Yeah, I agree with that. I agree with Bob's earlier point that there are things that machines do really well. There are things that humans do really well. Machines are really good at combing massive amounts of data and abstracting certain insights. When it comes to certain classes of reasoning over that data, machines are terrible at that, particularly when you're dealing with fuzzy questions that don't lend themselves to easy outcomes. So the more you can think about marrying the good things that machines do and the good things that humans do to help humans make better decisions and make better decisions based off of a better survey of the data that's available, I think you get into a realm where you have a kind of a positive symbiosis of these two domains, and that generally produces good outcomes, particularly when you're dealing with outcomes that implicate the lives of people.
So, and just one final comment. So, I mean, you mentioned it. So, this is about helping society make better choices, not just making algorithms better choices. So it's about how you, and Courtney touched on this, how you get the best of both worlds, how you can have algorithms kind of replace the shortcomings of human decision making, and humans replace the shortcomings of algorithmic decision making. When you're dealing with humans, there's an inherent limitation, is that humans, no matter how well educated and sensitive and forward-looking they are, they will always have subjective bias. Whereas in algorithms, where theoretically a bias could be ingrained in this algorithm, it's a matter of changing the recipe to account for that, and it's an objective process. Whereas human decision making will always have this inherent flaw that we can't always really protect against without better reliance on these kind of automated systems. So. With that, thank you all for coming. We'll be sticking around for a little bit if you have any follow-up questions. Just as a reminder, this has been recorded. We'll be posting it on our website afterwards. Feel free to take our articles and leave a business card in the fishbowl so you can sign up for our newsletter. We'll give you notifications of what else the center is up to. And please join me in thanking all our panelists for coming.